All right, welcome back. So lesson 33, we're going to be doing introduction to trigonometric equations. All right, so we talked a bit about the cast rule last time and the unit circle. It's really, yeah, it's going to be kind of a bit more the last questions we're doing on the last lesson there. So let's kind of just jump right into it. I think it'll make a bit more sense. So here's an example of something that we're solving, right? So looking at this, we're solving for what would this angle be in order for all this stuff to happen, right? And it's got to be between 0 and 360 degrees. Well, what we're going to do for these questions is we're going to solve these things algebraically so that we just have like just sine theta is equal to something. And then we're going to look to our unit circle. Then we're going to look to figure out what theta would have to be to make it true. All right, so let's do the first one here. It's kind of a bad example, this first one, but I'll kind of show you. So let's just solve this thing algebraically, right? So I'm going to bring 5 over to the right side and make it positive. So we end up with 4 sine theta is equal to 8. I just brought this 5 over to the right and added it, so 8. Divide both sides by, divide both sides by 4, and I get sine theta is equal to 2. So now just, if we think about this for a second, right? What I would be doing is I'd be looking for, these values, right? Sine theta is my y, right? So that's what I'm looking for on my unit circle here. Well, 2 doesn't really make any sense, right? Because 1, right, up here, that's as high as I can get. If I'm on the unit circle, I'm not going higher than 1. So an answer of 2 doesn't actually work. So that's why I said it was kind of a weird one. There's actually no solution to this one. Kind of a funny question to do first, but all right, so let's do this one now. All right, so we got 7. We've got 7 cotan theta is equal to or minus 4, yada yada yada, and it's between 0 and 4 pi. All right, so now just the same way that you would solve for these things. Let's say if this was x and that was x, I think you guys would know what to do then, right? You get your x's to the same side, and then your numbers to the other, and then solve for x, right? So let's do that now. Let's just collect like terms, right? So I'm going to say this is 7 cotan theta, and I'm going to bring this 6 cotan theta over, so minus 6 cotan theta is equal to, I'm going to bring this 4 to the right side and add it, so that's going to be, so we got negative 5 plus 4 on that side, and now I'm just going to collect my like terms. So we get 7 minus 6 is 1, so that's just cotan theta is equal to negative 5 plus 4 is negative 1. Now, I'm not a big fan of looking at it as cotan theta because I don't really know what that means, right? I'd rather it tan theta. And what I would do here is I would just flip this upside down, right? Negative 1 over 1, so that's 1 over negative 1. In the end, it doesn't really matter, does it? It's equal to negative 1. So tan theta is equal to negative 1. All right, so now I got a bit more to work with here, right? So now if I'm looking at my unit circle, I'm like, okay, so tan theta, tan happens when it's y over x, right? So when it's this guy over this guy. Well, I got 1 for an answer. Well, where is that going to happen? That's going to happen when I've got like root 2 over root 2, right? That would give me 1. But it's negative. So where is it negative? So again, you could use your cast rule, or you could really just figure it out from your unit circle there. So cast, where is tan negative? Well, tan's negative over here and over here, right? So those are really going to be our answers. But the other thing to look out for is it says it's between 0 and 4 pi. We should really have 4 answers here, right? We're going to have an answer to here, that's 1. An answer to here is 2. And then 3. And then 4. So in the end, we're after 4 answers. Okay, so where is this going to happen? So now it might be useful looking at the unit circle. It's going to happen here, right? We got root 2 over 2 divided by negative root 2 over 2 would be negative 1. So 3 pi over 4. It is also going to happen here, right? 7 pi over 4. Okay, so let's do that for now. So it's going to happen at, sorry, what did I say? 3 pi over 4. So theta is going to be equal to 3 pi over 4. Also 7 pi over 4. And then for the other ones, well, here I just want to show you something too, how we could have got that 7 pi over 4, right? We could have got that 7 pi over 4 just looking at our formula sheet here. Just I want you to see these kind of 3 pi over 4 is up here, 7 pi over 4 is down here. That is 180 degrees away, or pi away, right? That's pi radians away. So what I could have done there is I could have said 3 pi over 4 plus pi, and then that would have given me the next answer there, right? That would have given me what we had. So if I called this 4 pi over 4, that would end up being 7 pi over 4, right? So that worked out. So 7 pi over 4. And now to find the other answers, we can do the same thing, right? You can say, 7 pi over 4 plus pi, or, hope I'm not confusing you here, we could have went 3 pi over 4 plus 2 pi, right? 360 degrees would give us the next one as well. So we could do that. So let's say 3 pi over 4 plus 2 pi, okay, and that's usually over 1. So that would be 3 pi over 4 plus, I could call this 8 pi over 2. Sorry, not 8 pi. Yeah, sorry, 8 pi over 4, right? So 8 pi over 4, so that ends up being 11 pi over 4. So that would be our next answer, right? 11 pi over 4. That answer was this, right? That was not that went past that. This was our third answer, was right there, right? That's the one we just found. And now the next one, right? You could just add another pi if you wanted to, or you could go this answer that we had here plus 2 pi. Like there's a few ways to get it, right? So let's go, I'll go 11 pi over 4 plus pi. So we got to go halfway around again. Oh. Okay, so that's going to be 11 pi over 4. I'll call that 4 pi over 4 now. So this ends up being 15 pi over 4. So that was our next answer. 15 pi over 4. Okay, so there's all of our solutions. There should be 4 solutions to our equation now. All right, hopefully that made sense and didn't confuse you guys. Okay, number 2. So what we are going to do on this one, if these were x's, I think you'd have a lot easier time looking at it, right? Let's write it like that for a second. This would be the same as x squared minus 3x is equal to 0. That's not so bad, right? I think you could tell we would factor out an x and then just see what it would have to be to make it equal to 0, right? So we're going to do the same type of thing, but with the tans. Oh, one thing here too, just so you remember, when you've got tan, like squared theta, that's the same thing as tan theta squared. It's just written a little different. I'm not sure why they write it that way, but yeah, it means the same thing. So if we were going to rewrite this, we could write this as tan theta, like that's what we're factoring out, right? Tan theta. And then we'd end up with still having a tan theta in there, minus, and then this one was factored out, right? So it's minus 3 is equal to 0. Okay, so hopefully you can see that we've got 2 solutions now, right? We're going to have one solution where tan theta is equal to 0, and we're going to have another solution where, well, tan theta minus 3 is equal to 0. Okay, so let's solve for both. So first off, let's do the one to the left first. So tan theta is equal to 0, right? Well, where is tan theta equal to 0? Well, maybe it'll be helpful to look at the unit circle here for a second. So where is tan theta equal to 0? Remembering that tan theta is y over x, right? Or sine over cos. So sine over cos. So if I look, let's say up here, because it's going to be either like this one or this one, right? If I look up here though, right? Sine over cos, in this case, that would be 1 over 0. Tan would be undefined at that point, right? 1 divided by 0 is undefined. But if I look down here, right, at this one, well, that's going to be at, 0 divided by 1, right? That's just 0, so that's good. So it's going to happen at 0. But then if I look over here too, same thing. 0 divided by a -1. That's going to be 0, right? So both 0 and 180 degrees would work, or 0 and pi would both be answers. Give us, oh yeah, sorry, and the other thing we're going to do is we're going to write this out as a general solution. So that means that there could be an infinite number of solutions. So I'll show you how to do that. So this is going to happen. So we figured out this is going to happen at 0 degrees. Oh yeah, our answer's at degrees, right? 0 degrees, and then it would happen again at 180, and then it would happen again at 360, right? And on and on and on forever, right? So what we do instead is we're going to say, okay, our first angle would be 180 degrees times n, where n is a member of the integers, so like counting numbers, right? So that's pretty much it. We're just, because this would work for every one now, right? So if you think about the numbers I could throw in for n, if I threw 0 in for n, then my answer would be 0, which is true. If I put in 1, then that'd be 180. If I put in 2, that'd be 360. I could even go the other directions, right? I could put in -1, and I'd end up with -180. You know, so it works for all of them, right? All the way around the circle. Hopefully that was all right. Okay, and then our second answer from this one, right? We can write it out. So we'll say tan -3 is equal to 0. Okay, so we'll say tan theta, sorry. Tan theta is equal to 3. So now I got to figure out where is that equal to 3. Well, it's not really anywhere on my unit circle here. I do know, though, if I did my cast rule thing, that +3, so this would be here and here, right, is where my two things are going to be. So I'm not going to be able to make 3 from anything on here, right, because tan is opposite over adjacent, or y over x. I can't really, you know, whether this or any, like, I can't make 3, right? √3 I was able to do with these ones, but I can't make 3. So if that's the case, all we can do is just do second function. So maybe we forget this. We did it a lot, like if you took physics or anything else, right? Angle is equal to tan -1 of 3. Okay, so you can do it that way too and get a decimal answer. So if we did that, we end up with 71.565 degrees. And now I just need a way of saying this for every time it does that, right? So that was this angle that we just found right there, right? That was that one. So theta is equal to 71.565 degrees. And now are you okay with saying if I added 180 degrees, I'd be to the next one, right? And then if I added 180 degrees, I'd be to the next one, and then the next one, and on and on and on forever. So we just need to write that out. So it's going to be our original angle plus 180 degrees times n, where n is a member of the integers. So that would be my answer for the next one. Maybe I call that Q2, right? So those would be like that would be a full solution to that problem. All right, let's go back up and do the next one. Okay. Again, if this one for B, if this was written as like with x's, I think it would look pretty like obvious what you should do. But this is a cosecant thing, kind of throws people off. But what I'm going to do, I'm going to bring this tan over to the left and make it equal to 0. So let's rewrite this. Cosecant squared theta, it's kind of like x squared, right? Minus 3 cosecant theta minus 10 is equal to 0. All right, so I got something squared minus something x minus a number, right? I got to factor this. All right, so I know this is going to be cosecant theta, and this one would be cosecant theta. And I'm looking for numbers that multiply to 10 and add to -3, -10 and add to -3. This ends up being 2 and -5 are my answers for this one. So you can see again, I'm going to have two different ways to approach this, right? I've got the first one. this needs to be equal to 0, and then on the left, that needs to be equal to 0. So we'll do the one on the left first. So cosecant theta is equal to -2. Okay, well, if I rearrange, I could say sine theta. It's just, well, so cosecant theta is equal to -2/1. Sine theta is equal to -1/2, right? I could have replaced this one with 1/sine theta, but that's how it turns out in the end, right? So sine theta is equal to 1/2. Okay, so where is sine theta equal to 1/2? Well, you could use your cast rule thing again, or if you've already made a formula or a unit circle, where is sine theta equal to -2? So remember what we're looking for here, right? It's our y value. Well, it's equal to -2 right there, right? Or sorry, -1/2. And it's equal to -1/2 right there. So my answers here are going to be 7 pi over 6. And then it would happen again at 11 pi over 6. Okay, so theta is equal to 7 pi over 6. And 11 pi over 6. But we need like the actual answer, right? That's like written out. So we're actually going to split this thing into two answers here. So why we're doing this. So this 7 pi over 6, right? I don't have a good way of saying 7 pi over 6 and then plus something to get me to 11 pi over 6. So what I'm going to do is I'm going to say 7 pi over 6 plus 2 pi to get my next one. And I'm going to say plus 2 pi n, right? Because that's going to just keep on, like, you know, I'm going to go 7 pi over 6 and land on that every time I go 360 degrees, or 2 pi radians, all the way around, right? And then I'll have a second answer where I say 11 pi over 6 plus 2 pi, right? To account for every time I go around. All right, so let's go. So the first answer, I'll say Q1 is going to be equal to 7 pi over 6 plus, now remember, I'm going 360 degrees around to get the next one, right? So 2 pi radians around times n, right? Because that's 1, 2, 3, right? All the way around. And that's really going to be it. 2 pi n. Technically, I should say where n is a member of the integers as well. That would be like a full answer, right? So that's my first angle. My second angle, Q2, I'm going to use this one. 11 pi over 6 plus 2 pi n, where n is a member of the integers. Okay, that goes around. So that I've got two answers already, and I haven't even got to the second part of the question yet. Right, so that's that one. Now I'm going to do the same for this guy, right, for this one now. So let's go, okay, where is cosecant theta equal to 5? All right, well, that'd be the same thing as where is sine theta equal to 1/5. Okay, so again on this one, this kind of sucks because this isn't on my formula sheet, or on my, sorry, unit circle, right? What I was looking for was where it's 1/5. There's no 1/5s here. So the only thing I can do is go theta is equal to, and then sine -1 of 1/5. So theta is going to be equal to 0.201. All right, so now there's really one of my part answers there. And let's just do the cast rule again for a second. And realize that this thing is positive, right? There's sine is positive in this case. So that would be this and this, right? What I just found, right, this angle right here, that was this angle. Okay, so that's that one. Now, if I want this angle, right? So from the one from there to there, well, what I'm going to do is I'm going to go pi, right? So that was angle 3, let's call it. So now for the next one, if I go pi, or 180 degrees, right? So starting from here, and I subtract this angle, right? Because that's my reference angle. So pi minus 0.201. That should give me my second angle that we're going to deal with here. So that's going to be, so our Q4, if you subtract pi minus 0.201, you get 2.940 radians, right? So in the end, we just need the right way of writing this, right? So Q3, why am I saying Q? Angle 3, or theta 3, would be, so this one, 0.201 plus, now it's going to be all the way around, right? 360 degrees, or 2 pi radians around. So it's going to be 2 pi n, right? For every time you go around, it has to be a new integer, right? And then technically you'd say where n is a member of the integers. Okay, so there's our third angle, and then the other one's the exact same, but just a different number. So angle 4 is going to be this one, 2.940 plus 2 pi n, where n is a member of the integers. Whew. Wow, that took a long time. All right, so that was that one. Let's keep going so we can get this done in a reasonable amount of time. All right, number 3. If cotangent theta is equal to negative 5/9, determine the value of cos theta if pi over 2, or if theta's got to be greater than pi over 2 and less than pi. All right, so let's just kind of think about what that last part of it meant even. Pi over 2 was 90 degrees, right? That's up here. Pi was over here. They're saying that it's like somewhere in that quadrant. Okay. So now, cotangent is equal to negative 5/9. I don't think well with cotangents. I don't like it. My brain doesn't think that way. So I'm going to rewrite this as tan theta is equal to negative 9/5. Right, just flipping those two. All right, so then I'm thinking, all right, what is it that I actually have here? Well, remembering, top one is my y, right, or opposite. Bottom one is my x, okay? And I'm in this quadrant. And I kind of want to know which one's the negative and which one's the positive here, right? Because it could be negative 9 or it could be negative 5. I don't really know. But if I'm looking at, at this, right? I'm kind of making a triangle here. Well, which one's negative? It's got to be negative 5, right? The x value's got to be the negative because the y value is going up. So this would be 9. So negative 5, 9, right? And I need to know cosine theta. Well, the only way I'm going to be able to figure out what cosine theta is if I know what, so remember cos is opposite over hypotenuse. So it's going to be, so opposite would be 9, but I don't know the hypotenuse, right? 9 over something. You can probably see where this is going again. We got to do Pythagorean theorem. So let's figure out the hypotenuse here. So I'm going to say 9 squared plus 5 squared, or negative 5 squared, doesn't matter. C is equal to c squared. Okay. And if you do that, I'm just going to do it all together, you end up with the square root of 106 for c. Okay. So that's what we had here. Maybe I'll draw a triangle over here too. So let's say you actually drew this out. This would have been 9 on this side, negative 5 on this side, and now we've got root 106, right? We know that now. Okay, so that's all we've done so far. So now I can quite easily say, well, cos theta is equal to, it's supposed to be x over r, right? That's what it is. So now I know all of my sides of my triangle, so I can just plug it in. So cos theta is equal to negative 5, right? Negative 5, adjacent side, over root 106. That technically is my answer, but we don't like these irrational numbers being in the bottom, so we'll say root 106 on the bottom, so root 106 on the top. Cosine theta is equal to negative 5 times root 106 divided by 106. And that would be my answer. All right, that's it. So those questions are for homework.